Okay, class, so welcome again to our next topic for the graphical solution of the linear programming. So, in our first topic, we have defined linear programming and for the linear formulation of linear programs or linear problem formulation. So, this is a collaborative effort of your instructors in prescriptive analytics, the par incorporation problem as a linear program. So let us discuss how we might find the optimal solution. So the optimal solution must be a feasible solution, and a feasible solution is a setting of the decision variables that satisfies all the constraints of the problem. The optimal solution must also have an objective function value as good as any other feasible solution. So for a maximization problem like par incorporation, so we know that our problem for our par incorporation is to maximize the profit. This means that the solution must be feasible and achieve the highest objective function value of any feasible solution. So to solve the linear program, then we must search over the feasible region, which is set of all feasible solutions, and find the solution that gives the best objective function value. So one solution for that is graphing or to model the two decision variables into graphs to find the feasible region. So let us discuss now about on how to graph our mathematical model. Okay, class, our model is, we have to model rather, the mathematical model, which is the max 10s plus 90. So take note that S is equal to standard in standard bags, and D is for deluxe bags. For the cutting and dyeing, and it is subject to constraints 7 over 10 S plus 1D, less than or equal to 630 for the cutting and dyeing, 1 half S plus 5 over 6 D, less than or equal to 600 for the sewing, and 1 S plus 2/3 deluxe bags, hours is less than or equal to 708 finishing for the finishing, and 1 over 10 S plus 1/4 deluxe is equal or is less than or equal to 135 for the inspection and packaging. So first, we have to compute, of course, the cutting and dyeing. So let us subtract or let us transpose the value of deluxe bags and the standard bags. So it is equal to 630, right? So assuming that, okay, so let us write again 17 S plus 1 D. 17 S plus 1 D is equal to 630. So, in here class, so 1D is already equal to 630, and 7 over 10, 7 over 10S is equal to 630. So the deluxe bags is equal to 630, and then 710S, let's get the reciprocals of this number. Multiply it to 10 over 7. Okay, so mawawala yan. So S for the standard is times, eto pa pala, 630 times 10 over 7. So 630 times 10 is equal to 6,300, right? Divided by 7. So what is 6,300 divided by 7? So it is equal to 900. So the S now class, and the S now class is equal to 900. So for the cutting and dyeing is for the deluxe we have 630, and for DS standard is equal to 900. So let's try to graph the solution. Okay. So this yung sinabi natin kanina, it is for the cutting and dyeing we have deluxe is equal to 630, and for the standard we have 900. So let's try to graph that one with our with the x and y axis. We have here, let us draw the graph. Okay. So this is 0, right? And then 200, 400, 600, 600, then 900, then 900. So we have here for the deluxe bag, we have to put below or sa Y pala, sorry. So deluxe bags, it should be here, and for the standard, the x-axis. Okay, so let's graph. For the deluxe, we have 630. So, meaning, nandito yung point niya, 630. And then, for the standard, we have 900. So, nandito siya. Just be careful with your graphing kasi kung hindi maganda yung pagka-graph, then hindi magiging okay yung solution natin for the optimization for our mathematical model. Okay, class. So another another constraints that we have here in our mathematical model is the sewing and the sewing, right? So our problem or our constraint is one half. Okay, one half. We have one half. Sorry, I can't write. Okay, we have here one half S plus 5/6 D is equal to 600. So in our solving class, we have to transpose again. Okay, one half. So let us first find the value of S. So one half S is equal to 600. Okay, let's get the reciprocal and multiply it. So S is equal to 600 times 2. We have 2 divided by 1. So, magiging yung S natin magiging 1,200. So, the value of S now for sewing is 1,200. So, yung S natin 1,200. So, nandito siya sa this part siya. And then, for the other one, we have 560. 560 is equal to 600. Okay, let's transpose again. Then let's get the value for D. D is equal to 600 times 6 over 5. So 600 times 6 is equal to 600 times 6 is equal to 3,600. Okay. 3,600 divided by 5 is equal to 720. So the value now for the deluxe bag is 720. So yung 720 natin, it might be here. Okay, dito siya. And then, let's connect the 1,207.20. So, magiging ganyan siya. Okay, for the next one, we have the finishing. So, okay, let us label the first two constraints we have here. The first one, cutting and dyeing. The second one, we have sewing. Okay, and for the third one, we have finishing. So, one is our model is, or for the constraints finishing, we have 1S plus 1/4 D. It should be less than or equal to um, I'm sorry, 2/3. It should be 2/3. So 1S plus 2/3 D is equal to 708. So in here class, we have to, okay, for the standard, so automatically it is equal to 708. So S now class for the finishing is equal to 708. So while we have 2/3 and D, so let's find the value of D is equal to 708. So let's get the reciprocal, 3 halves, and then slash D is equal to 708 times 2, or 3 rather, over 2. 708 times 3 is equal to 2,124. Divided by 2, it will be 1,062. So, D now class for the finishing is equal to 1,062. Okay, so let's graph the two variables now. We have for the standard, we have 708. So it means it's here. So the point is here, and then between 800 and 900. And for the deluxe, we have 1,062. So it means that it is above 1,000 in the y-axis. So let's connect the two. Okay, so that's it for the uh, finishing of the constraints for our linear problem. Okay, so thirdly, or for the mathematical, or for the fourth constraints, we have the inspection and the packaging. So the model for the inspection, or the for the constraints inspection and packaging is 1/10 S plus 1/4 D, and it should be less than, or always less than or equal to 135. So we have to find first the value of S. So S is equal to 135, 110S rather. So 110S is equal to 135. So let's transpose again, times 10 over 1. So S is equal to 135 times 10 over 1. So times 10 is, of course, it is equal to 1,350. So our S now class is 1,350. So for the S, let's see. So nandito yung point niya, should be nandito yung point niya. Keep. Nandito yung point niya, nasa gilid, right? 1,350. So, masyadong magulo yung graph natin. Dapat hindi siya magulo para makuha natin talaga yung optimal solution using graph. Kasi kapag magkakamali tayo doon sa graphing or the graphical solution, then mali lahat yung gagawin nating optimal solution for the mathematical model. So, we have here the point. We have 1,350, right? Okay, so let's i-move ko because yun nga, wala tayong paglalagyan ng graphical ng 1,350. going back, okay, so we have here the point 1,350. So let's assume that this is 1,200, then 1,400 ito. So 1,400, so nandyan siya. And then for the deluxe, okay, let's compute again for the deluxe. We have 1/4 D, right? 1/4 D is equal to 135. So yung 1/4 D, D is equal to 135 times 4. Okay, so 135 times 4 is equal to 540. Since yung denominator natin is 1, so 540 na talaga siya. So 135 times 4 is equal to I think yes, it's 540 divided by 1 is 540. So the value of D now class is equal to 540. Okay, so let's try to graph it. 540, where are you? Okay, below 600. Okay, let's connect the two lines. 540 for the deluxe and standard. Okay, 103.40. So that is our graph for the final constraints, which is the inspection and packaging. Okay, class. So our final graph now is shown in our presentation. So for the finishing, we have 1,000. I think it is 1,062. So nasa taas siya ng 1,000, and then for the deluxe bags and 1,062 hours, and for the standard bag we have here 708. So dito supposedly dito siya. So nagkamali ako. So nandito siya. So yun yung finishing. For the inspection, based from our solution a while back, we have for the standard 1,350. So nandito siya. So below 1,400, maybe nasa gitna siya dito. Okay, 1,350. And for the deluxe, we have 540. So, nandito siya. So, connected sila. So, anyway, class, I will be showing you a clearer view of this graph later on. So, parang yung solution lang natin, inilagay lang natin kanina doon sa mga constraints, yung na-solve nating problem para ma-analyze ninyo or makita ninyo na ganun yung pagka-graph nila. Later on, I will show you a more or a clearer view of the graph. And then we have sewing. So in sewing class, we have the standard which is 1,200. So wing 1,200. So nandyan yung point niya, and then yung deluxe bags we have here 720. Yung 720, so nandito siya. And lastly, we have the inspection and packaging, the last constraints of our mathematical model, the inspection and packaging. We have the standard, which is 1,350 and 1,350 and 540. So that is our graph. So now class, let us find the points for the feasible region of our graphical solution for our mathematical model. So it means that the feasible region now class is here. So feasible tong mga to. Pero kapag nag-exceed na siya, hindi na siya feasible for the optimization of our problem. So ito yung mga feasible region kung saan sila nag-meet lahat ng mga constraints natin sa mathematical model. Okay, class. So this is our final graph. So we can see here a clearer view of our graphical solution of the mathematical model or the linear program. So just like what I've told you a while back, when we say feasible solution, it is a setting of the decision variables that satisfies all the constraints of the problem. So the optimal or the feasible region now class here is based from our presentation, we have here the area for our feasible region. So this part. Okay. So there are points for our linear problem or the graphical solution. The point one, of course, 0 to 0 kasi nasa area pa lang siya ng feasible region. And then the second one, we have point two. So the point two here, 708. Okay, yung 708 natin kanina and 0. Okay, for the S, 708 and then 0. And then for the third point, we have 540. So, nandito siya. Yung third point natin, second point siya, first point, and then we have the fourth one. The fourth point is in 300 and 420. So, nandito siya. And then the last one is the fifth point is 0 and 540. So 540 sa deluxe. So those are the feasible regions of our optimization problems or graphical solution for the optimization model. Okay, so the optimal solution now is in 3. So since yung 3 natin, parang yun yung pinaka-optimal na solution natin. So the S there is equal to 540 and the D is equal to 252. So that's why minsan sa pag-graph kasi nagkaka-mistake tayo. So there are limitations of the graphical solution. That's why meron na-introduce na Excel solver for Microsoft Excel para mas clear or mas yung output niya is mas exact or mas accurate kesa dun sa graphical solution. And graphical solution or the MS Excel solver will be discussed to you next meeting. Okay, so for the assessment after viewing or watching this video presentation or this video recorded discussion, I will be giving you a quiz, or we shall be giving you, kasi this is a collaborative effort of your instructors in BAFBRES, Fundamentals of Prescriptive Analytics. A quiz of maybe 20 points will be given to you next meeting. Okay, class, so if there are questions for this topic, you may ask me through our messenger group chat or in our Google Classroom. So, okay, so for now, goodbye class. So let's discuss again. Let's discuss next meeting about Excel solver for linear programming, problem formulation and solution. Okay, goodbye class.